Let's take a look at question number 8. We are to find the limit as h approaches 0 of 2 times the square root of 4 plus h minus 4 over h. So if you closely examine this limit, it looks very much like the limit definition of a derivative. Remember the derivative at a specified value, let's say f prime of a, using limits is a limit as h approaches 0 of f of a plus h minus f of a divided by h. So it looks as though this is the derivative of a function at a specific value. So let's see if we can determine what that function is. Okay? So if you take a look at these two formulas, it appears as though this is f of a plus h, where a is equal to 4. Okay? So considering this formula, let a be equal to 4. We have f of 4 plus h equals 2 root 4 plus h. Now, what do you think f of 4 is going to be? You simply take out the h component, and then we'll have 2 times the square root of 4. So the question now is, if I simplify this term, do I end up with 4? Let's see. So we have 2 times 2, which is 4. That's exactly what this is right here. So we can rewrite the problem as follows. The limit as h approaches 0 of 2 root 4 plus h minus 4 over h. This original problem is the limit as h approaches 0 of 2 root 4 plus h minus 2 root 4. That entire expression divided by h. Okay? Now, what this limit is telling us is to find the derivative of a function at a particular value. So what is that function? F of x is equal to, instead of 4, we are going to input 2 root x. Okay? So this limit is asking us to find the derivative at this function when x equals 4. All right, so the problem can be rewritten as find f prime of 4 where f of x is equal to 2 root x. Okay, so this is the limit definition of the derivative at a point. So I just rewrote it in this form. Now we're going to use the differentiation rules to find the derivative of this function and evaluate it at x equals 4. So let's go ahead and do that. F prime of x is going to be 2 times the derivative of root x is 1 over 2 root x, which equals 1 over root x. So this is the derivative of the function. Now we want to evaluate it at x equals 4. We'll have 1 over the square root of 4, which is 1 over 2. Okay? So this is one way of finding that derivative right here by basically using the limit definition of a derivative. You can find the limit of this expression right here as h approaches 0 by rationalizing the numerator. Okay, you can do that. You can find this limit by applying that procedure. But you can also take advantage of the differentiation rules like we did here, and we see that our final answer is 1 over 2. Let's take a look at question 9. So for question 9, we're to find the derivative of 3g divided by 2f if f and g are differentiable at x equals 4 and f of 4 is 2, f prime of 4 is 2, negative 2, sorry, g of 4 is 3, and g prime of 4 is equal to 5. So let's go ahead and find this derivative. Now we can factor out 3 over 2 from this expression right here. So the derivative ddx of 3g over 2f can be written as 3 over 2 times the derivative of g over f. Okay? Now that we have the quotient of two functions, what formula are we going to use? We're going to be applying the quotient rule. Okay? So u over v prime is equal to vu prime minus uv prime divided by v squared. Alright? So let's apply that here. We're going to have 3 over 2 times f g prime minus g f prime over f squared. Okay? Now how did that happen? Well, we took the numerator function and called it u, and then the denominator, we called it v. So in this problem, we're looking for the derivative at x equals 4. So we're simply going to now input these values into our expression down here. Okay, so we'll have 3 divided by 2 times f is 2 times g prime of 4 is 5, as we can see here, minus g is 3 times times f prime, which is negative 2, and that entire expression divided by f squared. F is 2, so if we square that, we have 4 down here. Okay, let's go ahead and simplify this expression. We're going to have 3 over 2 times 2 times 5 is 10, 3 times 2 is 6, and then this negative makes this a plus 6 divided by 4. Okay, now we have 3 over 2 times 10 plus 6 is 16 over 4. We have 3 over 2 times 4 over 1. 2 goes here 1, 2 goes here twice. And our final answer is 6. Okay? So that's a basic application of the quotient rule in finding the derivative of a function when it's presented in components like this. Okay? So there goes our final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions about this tutorial, or if you would like to request lessons for us to make for you, feel free to include it in the comments section below. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.